Okay. So tell me first, what do you think about the questions?
I haven't tried it yet.
All of you haven't tried yet. Okay. Okay, never mind. I will just continue the lessons. So I'll complete it. Okay.
Yes, that should be fine.
Okay. The next sections is called uh, complex summation. Okay. Complex summation. So this one is very special. We're going to use something related to GP. Okay, we use GP here. So GP, GP formula. Okay, so let's see. Let's say I have this example. Okay, let's see. By considering the expansions of summation n equals to 1, z power of 2n minus 1 to the n, okay, so show that this is true. Okay, so over here we will let z equals to cos theta plus I sin theta without the r, okay, or we can write it as ei theta. Okay, for this kind of question we will actually consider it in this way, unless there is some other thing involved, some other element involved, then we will only involve the r. So over here the notation n equals to 1 z power of 2n minus 1. Okay, so it's actually same as talking about when 1 put it inside. So I have a z power of 1 plus z power of this 2 put inside, you have a 3 plus z power of 5 until z power of 2n minus 1. Do you understand the notation?
Yes.
So do you see this is a GP? Can you see
Yeah.
that this is a GP? So it will follow the GP formula of uh, first term a times z power z square here. This z square power n minus 1 over z square minus 1. So far so good. Can you follow? Can you follow?
Why is it z square?
What is this x square? What do you think?
Uh,
GP.
Oh, GP. Okay.
Brian, follow? Okay. So I have a z of z 2n minus 1 of z
Okay.
square. Sorry, Karu?
Yeah, so shouldn't the denominator be 1 minus r square?
Hmm?
So like, are we using sum
The summation
for
formula, yes.
finite terms, right?
No, this is finite one.
Yeah, that's right.
This is not
Finite
infinite.
terms, yeah.
Finite terms, yes.
So isn't the denominator 1 minus r?
They are the same thing, Karu. They are the same thing.
But here our r is z square, right?
Yes.
Okay.
They are the same thing. Do you remember your GP? A 1 minus Rn over 1 minus R. A of Rn minus 1 over R
Oh,
minus 1 is they are the same thing,
okay.
right?
Yeah.
Okay, so we have this. So on the left, on the right, they are all in the complex form. So if we continue writing it out for the left and the right, let's see what's going to happen. So on the left hand side, I have summations n equals to 1 to n. Okay, So z here, as I say, we write in the form of cos theta plus I sin theta. Okay, 2n minus 1. So according to De Moivre theorem, 2n minus 1 can actually put in. Do you agree?
Yes.
So this is the same as talking about summation n equals to 1 of cos 2n minus 1 theta plus I of n summation of n equals to 1 of sine 2n minus 1 theta. Do you agree?
Yes.
Okay. So to answer the question, we are only looking at the real component of it. The question here only requires us to look at the real component of it. Therefore, we are searching for the real component of this term. Okay, we are looking for the real component of this term. So on the right hand side, I have z to n minus 1, z square minus 1. Okay, so to write as the real component, okay, maybe I need to do ei theta, e of 2n I theta minus 1 over z of 2i theta minus 1. The bottom is complex, so we need to rationalize it. Okay, we need to wait. Let me multiply this thing inside first. So I have e of I theta 2n plus 1 minus e of I theta over e of 2i theta minus 1. Now I multiply by the conjugate of the bottom. So I multiply by the conjugate e of negative 2i theta minus 1, e of negative 2i theta minus 1. This is the conjugate in the Euler form. This is the conjugate in Euler form. So top multiplied by the top, bottom multiplied by bottom. Top multiplied by top, we do the item carefully, one thing at a time. This one multiplied by this one. 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 Okay. Simplify the power. Minus I theta. This is a 1, this is a 1. They are a total of 2. This one, if you write it back in the cos and sine form, okay, the top I don't disturb first. I just keep it as is. the bottom, you'll see that minus I sine 2 theta plus I sine 2 theta gone, minus cos 2 theta minus cos 2 theta, I have two of them. Therefore, the bottom is a real component. Okay, we already rationalized the bottom. So what we want next is the real component of it. So by taking only the real component, I will get e of I sine 2n minus 1. So I have a cos of 2n minus 1 theta. This one minus, I have a cos of 2n plus 1 theta. This one I have a minus of cos theta. This one I have a plus of cos theta over the bottom 2 minus 2 cos 2 theta. The next part is simplifying. Simplifying until I get this thing here. Sine 2n theta over 2 sine theta. So, doing trigo, this one cancel off. Cos P minus cos Q. Cos P minus cos Q, I will get cos P minus cos Q, I will get negative sine of 2n minus 1 plus 2n plus 1 over 2 theta sine of 2n minus 1 minus 2n minus 1 over 2 theta over, this is 2, 1 minus cos 2 theta, 1 minus cos 2 theta is 2 sine square theta. Then, simplify thing. Okay, why I have a negative? I don't have negative here, never mind. I'll leave it there first. So, sine of minus 1, 1 cancel off, you have 2n theta, sine minus 2n minus 2n is gone, minus theta, sine of minus 2 minus theta over 4 of sine square theta equals to negative sine of 2n theta, negative of sine theta over 4 sine square theta. Cancel, 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 cancel. You have a sine of 2n theta over 4 sine theta. Done. Okay, I have a two, this is a 2, I have a 4. What's wrong? I'm missing a 2 here. The formula. Minus 2. 2. So 2 cancel. This is left with 2. Yes, done. Try to process. Just what you need to do is get used to the working. This is the type of question that that about 1.5 page or 2 pages of kind of working. Luckily, this is the hardest part, the last sections of the hardest part of your syllabus. Okay, remember yesterday I told you guys that there are final 2 parts, isn't it? One part is in the syllabus, one part is not in the syllabus. Okay, the final part is actually harder than this. Luckily, this is your, according to the syllabus, this is the hardest that you can get.
How many marks would this kind of question be?
A lot of marks. Definitely a lot of marks. And students have to do it fast as well. Fast and accurate. Right now, I break down into pieces. This is, of course, this over here is not in the proper proper working, because I'm trying to break down to the components to actually help you see it better. Okay. Okay, I'll let you try to rewrite the thing. I'll pause my recording first.